up, y'all? It's Mr. Canada. In this video, we will continue our discussion about how to write the domain and the range of a continuous function. What we're going to be focusing on here is lines that have infinity or unbounded domain and ranges. So let's go ahead and get started. So from the last video, we were talking about how we were writing the domain and range of a continuous function, and we talked about specifically what we needed to focus on for the domain. So if we wanted to find a domain, we focused on the x's, which was, in this case, we started from the left and we ended at the right. And if we wanted to write the range, we started from the lowest point and we ended at the highest point. So we're still going to be focusing on that same tactic and that same way of looking for those numbers. The only difference is that we're only going to end up with one endpoint instead of two. But we're going to talk about that a little bit more in just a second. To remind ourselves about how we write it, remember that we were talking about interval notation, which basically means that once we have our two endpoints, we're going to be using inequality symbols to differentiate the beginning and the end. Now, the big thing that we have to remember is that depending on what kind of endpoint we have, we're going to be using one symbol over the other. So for example, if we have a colored in symbol, we're going to be using the inequality sign with the equal to. And if we have an open circle, we're going to be using the inequality that does not have the equal to. So let's go ahead and start looking at how do we find a domain and range from these particular types of examples that have one endpoint instead of two. So look at this first one right here. One of the things that you'll notice is that there's an endpoint right here that's an empty circle, but then on the other side where we usually expected an endpoint, this time is an arrow. So what exactly does that arrow mean? Basically, the arrow means is that my graph or my line is going on forever. It's unbounded. So one of the key ideas that you have to realize is that sometimes unbounded behavior goes towards a certain number. And that number is basically infinity because it's growing so quickly that we basically can't measure it. So that's one of the key ideas here is that anytime that you see an arrow that's going off to the side, it basically means that the line is going on forever towards infinity. That's the big idea here. So how exactly do we write the domain and range of something that has infinity in it? Well, the strategy is still the same. We still want to think about left to right for the x and then lowest to highest for the y. Check this out. So let's say that we wanted to find the domain for this graph right here. Well, remember, we're going to start from the left and end at the right. Here's my left endpoint. My x right here is -3. So that means I'm going to start with -3. And because it's not colored in, I'm going to use the inequality sign that does not have the line. Remember that x goes in the middle. Okay, so now where is my right endpoint? Well, my right endpoint would have been right here, but there's an arrow there. So what does that mean? Well, that basically means that because there's an arrow, my second point or my second number is going to be infinity. So that means that this right here is going to be infinity. Now, one question you might ask yourself is, well, if it's infinity, what symbol do we actually use? Because it's neither solid nor not colored in. Well, here's the idea. Basically, infinity is an unmeasurable number. By unmeasurable, it basically means that we can't really reach infinity. We can go on the number line on forever if we won't actually reach infinity. It's an unobtainable number. It's an unmeasurable number. So if it's unmeasurable and we can't necessarily get to it, that means we're going to always be using the inequality sign that does not have the equal to symbol. That's super important. You have to make sure that when you're dealing with infinity, that you use the inequality symbol without equal to, because we cannot obtain infinity. The moment we do get to infinity, there's going to be an infinity bigger than that infinity, or a number bigger than that number. So we can't really reach it. That's basically the big idea with these, is that the strategy is the same. We're just thinking about infinity now because of that arrow, because it's unbounded, it's going on forever. So let's go ahead and see how we find the range for this. The range, lowest to highest. In this case, the lowest is located right here. So what is the lowest number there? Think about this. We know that the arrow implies infinity. So we know this is going to be infinity to begin with. But let's think about this. are my y values here positive or negative? Well, because I am below the x-axis, all of my y values are going to be negative. So one thing you have to include to this particular type of infinity is a negative sign, because we're going down. All of my y values are getting smaller and smaller as we move on. So that means this is going to be negative infinity. And because it's infinity, we are going to be forced to use the inequality symbol without the line. Y goes in the middle, and then we look for the highest point, which the highest point is up here. My y value up there is positive 6, so that means this is going to be positive 6. And again, I don't put the line because that's an empty circle. So what's the idea? Basically, the idea is if you see a line, it's infinity, but you should also keep in mind about what kind of infinity you're working with, because you might have a positive infinity depending on what part of the coordinate plane you're in, but you also might have negative infinity for the exact same reasons. Besides that, how we go about getting those numbers are the same. Domain is left to right, range is lowest to highest. Let's keep doing a couple of examples just to get a better idea about how we do these. So in this next example, we have this line right here. Again, we have an arrow, so we're probably going to be working with infinity. So let's look at domain first. Domain, left, and then right. So here's my left over here. We're going to go ahead and figure out what the x value is there. It's negative 4. So we're going to start off with negative 4. We put the inequality with equal to because it's colored in. And now we look for the right endpoint. Here's my right endpoint right here. There's an arrow there. So that means it's going to be infinity. And how do we know whether that's positive infinity or negative infinity? Well, all of my x values here are positive, so that means that this has to be a positive infinity. And because it's infinity, we are forced to use the non-equal to inequality. Okay, let's go ahead and find the range. The range here, lowest to highest. My lowest point is down here. My y value at that point is negative 6, so this is going to be negative 6. And then I put my inequality, the correct inequality sign, y in the middle. And then where's my highest point? My highest point is located up here. There's an arrow there. So that means I'm going to be working with infinity. Now what kind of infinity should we use? Well, all of my y values up there are positive, so that means I should keep this as a positive infinity. And we're going to go ahead and put the correct inequality sign there too. So how much different is it? It's not really all that much different. The only thing we're really working with here now is just infinite numbers. And that's okay. Just make sure that you're asking yourself what kind of infinity you're using and whether or not you're using the correct inequality sign, which is always going to be non-equal to whenever you're dealing with positive or negative infinity. Let's look at 2 more examples and then we can recap. Alright, so here's a different example right here. Let's go ahead and find the domain first. Domain is still going to be from left to right. So here is my left. So notice that I have an arrow to begin with. That means I'm going to start off my domain with an infinity. Ask yourself, what kind of infinity are we working with here? Well, all of my x values here are negative, so that means I'm working with negative infinity. So inequality sign, x in the middle, and now we look for the right endpoint like we always do. So here's my right endpoint. We're going to go up to the x-axis. My x value is 4. So that means this is going to be 4. Now let's look for the range. My range, lowest to highest. So here is the lowest point right here. What's my y value? Well, my y value there is negative 3. So we're going to start off with negative 3. And I'm going to put the equal to because that's a solid dot. Why? And now we're going to look at the highest point. The highest point is located up here, or it would have been right there. Because there's an arrow, we're dealing with an infinity. Now, ask yourself, should it be positive or should it be negative? Well, all of my y values up here are positive, so this should be positive infinities. And now we're going to put the correct inequality sign. Let's look at one last example to finish off our discussion about this. So here's another line with an arrow. Let's go ahead and talk about it. So domain first. Domain, again, left to right. I'm always going to be repeating that so we can remind ourselves that we're not doing anything different. So our left endpoint would have normally been right here. So I see an arrow, that should be infinity. Now ask yourself, what type of infinity are we working with? Well, all of my x values here are negative, so this is going to be negative infinity. I put the correct inequality sign, x goes in the middle, now we end with the right endpoint. So here's my right endpoint, my x value there is 3. So that means this is going to be 3, and I don't put the line because that's not colored in. Now we finish this off by finding the range. The range, lowest to highest. So my lowest point would be located over here, or it would have been located there. So again, because there's an arrow, we're dealing with an infinity. And again, ask yourself, what kind of infinity are we working with? Well, all of the y values here are negative, so this should be negative infinity. Again, why is it y values and not x values? Because range deals with all of the y values. So we're only focused on what's happening with y when we're talking about range. So here, we're going to be using the correct inequality symbol. And now, what is the highest point on our graph? Highest point's right here. What's the y value? It's positive 2. So that means this is going to be positive 2. So let's recap. How we write the interval for the domain and range of a graph that has an arrow, basically infinity, is still the same. The only thing you have to keep in mind is, remember that how you find domain is the same, how you find range is the same. Domain is left to right, range is lowest to highest. The things that you have to be asking yourself is this: if I do have a type of infinity, what kind of infinity am I working with? Look around the numbers and check to see if it's positive or negative. We've seen a lot of cases here where some of the infinities were positive and some of the infinities were negative. And the reason why it was one over the other was because it was in a very specific spot in the graph. And you have to remember that whenever you're dealing with infinity, you are forced to always use the inequality sign that does not have the equal to line. Do not use the equal to inequality when you're working with infinity. I hope you guys learned something new today. If you have any questions, leave them in the comments below. If you liked the video, give the video a like and subscribe to my channel for more Algebra 1 videos. As always, please take care, and I'll see you guys next time.